Next examples that I wanted to do were just some negatively charged VSEPR. We'll start with the ClO3. Has one minus charge, so that means it has added an extra electron because electrons are negatively charged. So we'll still just start counting electrons. Chlorine is group 7, or 17, so it has 7 valence electrons, and 3 oxygens, group 16, so 6 valence electrons for each of them, but there's 3, so it's 6 times 3. So that should be 25. But this negative means that it's gained another electron, and because there's no number there, you just assume it's a -1. So that means it has 1 extra negatively charged electron. So now our new total is 26 to work with. That's the only thing that is a bit different, just that first electron count. And for cations, remember you subtract because it's lost an electron. So then I take my guess. I'm going to put chlorine in the middle with all of the oxygens as far apart from each other as they could get. So I have drawn 2, 4, 6 electrons already, leaving me only 20 more to work with. So you're always going to try fill up the peripheral atoms, so the oxygens, the ones around the outer edges, first for valence electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And then that means I have 2 extra electrons to work with. After I subtract 18 from 20, I have 2 more. And then that means I have to just throw them on the center guy. So as soon as I've made a lone pair beyond chlorine now, I have to redraw my guess. I know that that lone pair is going to go on top as far apart from the oxygens as they can. Because now this is my AX3E. Trigonal pyramidal. But let's check formal charges first. Formal charge for each of these oxygens is 6 valence electrons, or group 6, sorry, minus 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 lone electrons, minus half of the 2 bonding electrons. So that leaves each oxygen with a -1 charge. So hopefully, if my molecule is only supposed to have a -1 charge, I have a -1 plus -1 plus -1 for each of those 3 oxygens. Leaves me a -3 right now on this molecule. So chlorine's going to have to be a +2, hopefully, so that a -3 plus 2 gives me back that -1 charge on the molecule. So let's just double check. Chlorine wants 7 minus 2 lone electrons and half of 2, 4, 6 electrons in the bonds. So that's 7 minus 2 minus 3, and that's why we get +2. So let me redraw everything for you. It's a bit messy. This guess is no longer good. So this is what we have so far. We have chlorine in the middle with a +2 charge on it, and oxygen around the edges with a -1 charge on it. So overall, it does give us a -1 charge because +2 minus 1 minus 1 minus 1 is a -1 altogether because it's like +2 minus 3. But the rule is you want to limit the formal charges. So oxygen means that it has a negative there, means that it has extra electrons. So what's going to happen is it's going to take one of its lone pair electrons, both of them, like 2, and it'll donate it into a double bond. Because the positive charge on chlorine means that it needs more electrons. So that'll help it out if oxygen were to give it to form a double bond. And I can know that it would happen twice because that'll only satisfy this chlorine to be a +1. And you could actually work it out, draw that intermediate diagram, find them formal charges. But I'm just going to skip that step. And I know that it'll have to do it twice because it's going to go double bond to one of them, double bond to a second one, single bond to an oxygen, and that'll leave me my -1 charge that I want. And I'll just double check for you guys here to show you that that oxygen now that are double bonded and the chlorines have a formal charge of 0. So the double bond oxygen, it'll only have 1, 2, 3, 4 lone electrons because I gave up 2 of them into that double bond. So group 6 minus 4 lone electrons minus half of 2 4 electrons in the bonds. That's 6 minus 4 minus 2, so that's our 0. This one will also be 0 because it's bonded the exact same way with 2 lone pairs and 2 bonds. So then finally we just have to check chlorine. Group 7 minus no lone electrons minus half of 2, 4, 6, 8, 10. 7 minus 0 minus 5. 2, 4, 6, 8, 10. I forgot to be drawing those lone electrons on chlorine. They didn't go anywhere. They're still there. Sorry. So let me fix that. It's 7 because group 17 minus 2 now because there's 2 lone electrons, and then minus half of the 10. Yeah, so that gives me back my 0 that I wanted there. So the final answer after all of that work, this is what you should have. Chlorine in the middle, double bond oxygen, double bond oxygen, and it doesn't matter which oxygens you choose for that double bond to exist at, because in reality, it's actually existing on all of them. So you just pick one and you run with it. All together, AX3E for trigonal pyramidal. And in 3D, that should be like this. And that's it.